The main application we're going to use linear algebra for is solving systems of equations. So you guys have all solved systems of equations before. It looks something like this over here: x plus 3y equals 6, negative 4x plus 2y equals 5. And you've used substitution, you've used elimination, you may have used graphical ways in order to solve a system of equations. We're going to learn a whole bunch of other methods that revolve around what's called writing a system of equations in matrix form. So given a system of equations, we can write it in the form of what's called ax equals b, where a contains my coefficients in front of my unknowns. So this 1 here, this 3, this negative 4, this 2. X contains my unknowns. It's full of letters. And then y, or b, contains my coefficients, or not my coefficients. B contains my constants on my right-hand side. So if I have a system of equations that looks like this here in generic form, here's equation 1, 2, 3, 4, 5, etc. A here is going to be a square matrix, most of the time, not all the time, but it's going to be a square matrix where the first row contains the coefficients from my first column, or my first equation. The second row contains coefficients from my second equation, and then I just keep going until the last row contains the coefficients from my last equation. So for this example over here, A is going to be a 2 by 2 because there's 2 equations. The first row is going to contain a 1 and a 3 because there are the coefficients from equation 1. The second row is going to contain a negative 4 and 2 because those are the coefficients in front of my unknowns in my second equation. Keep in mind, these rows or these columns correspond to my unknowns. So these two numbers both belong in front of my x unknown. These two numbers both belong in front of my y unknown. So you can set up this grid that tells me, oh, this is the coefficient in front of y for my second equation. That's how you set it up. Like I said, your x, so here's x. X contains your vector of unknowns. It's just full of your letters in the same order that it is up here. So x, y, just literally pull them down. And then equals b. B is full of the constants on your right-hand side. So it's just these numbers, where the first one is from equation 1, the second one is from equation 2. And you can expand this out for any size system of equations. So if you have 4 equations, 7 equations, 20 equations, 100 equations, you can write it in the form of ax equals b. There's also the form of yc equals d, where y is the same as x transposed, c is the same as a transposed, and d is the same as b transposed. So C, the first column, is from equation 1, the second column is from equation 2, etc. The first row is for my first unknown, the second row is for my second unknown, etc. The nice thing about writing our system of equations in these forms is it's always going to be the same way to solve for them. We can just find the inverse of A every time and multiply it by B. So ax equals b. Remember, we can't just say x equals a, or we can't just say x equals b divided by a. We can't do that. That's not valid. We can't just divide. We can multiply, though, by the inverse. So if I say a inverse times a, x equals a inverse times b. This equals identity. So if ix equals a inverse b, which is just x equals a inverse b. And this is the same every single time. So all we need to do is find the inverse of A and multiply it by B. And we will go through an example and show how to solve a system of equations in Matlab.